All right, so far, if you're following my videos, we've talked about how to graph logarithms and that logarithms are inverses to exponential functions. But what we have not talked about is what really is a logarithm and how do we evaluate it. So now that I've kind of given you an introduction of that they're inverses to exponentials and how to graph them, now I want to take you through some actual math work with them. If we look at this, this says what is the logarithmic form of each equation. Now we have said that they're inverses to exponentials. So what exactly is going on with these things? Let me grab just a side note piece of paper here. And let's talk about inputs and outputs with these equations. So if I'm talking about an exponential function, like 2 raised to the power of x is equal to y, my input here is the x value. It's an exponent, right? Let's make that equal sign look a little bit better. If I'm talking about a logarithm, I'm going to say the y is equal to log base 2 of x, right? So my input here is x and the output is y, just like input here is x and the output is y. So just be aware of where your inputs and your outputs are on these things. Here's my input on that exponential function, and then when I square the 10 here, I get 100. So the logarithm of this would look like this. Remember that we call in exponential form, this right here is my base. Well, when I'm talking about a logarithm, remember in this example we had 2 as the base. Notice 2 is the base right here in the exponential form. In the log form, 2 is my base also for that logarithm. So it's got the same base, whether you're talking about exponential form or logarithmic form, we still have a base in both. And when we switch between the two, that base does not change. So looking at this one, my log had better have a base of 10 when I switch it to that form. So I've got log base 10. I'm not going to write the 10 there because remember what we talked about. If there's nothing written right here, it is base 10. It is what we call our common logarithm. So I don't have to write the base on this one just because the base is 10. And so I've got the log base 10 of something is equal to the 2 right here. And so in this case, 100 goes right here. So look that over. That's how we switch between the two. Here, my input was my output over here. And my output on the logarithm is my input in the exponential. Remember, they're inverses to one another. So they should undo one another. In this case, when I input 100 into the function, out pops a 2. When I take that 2 and input it to the function up above, out pops a 100. That's why they're inverses to one another. So as you do these, if we did write a 10 in here, because that's what it really is, we just don't typically write it. When you switch back and forth between the two, I should be able to take this 10, and this is how I kind of learned it when I was just beginning this a long, long time ago. If I want to check my work, I should be able to slide this 10 right here and raise it to this number. So it's 10 squared should equal 100. Do you see how it's 10 squared equals 100? I just think about sliding that base over and letting this right here is my exponent. 10 squared equals 100. So we're going to do that on all those, kind of check them that way. And if that helps you, use it. If it doesn't, then find something else that works. This one right here, number 2, we've got 81 equals 3 to the 4th power. So it's an exponential form. The base is 3, right? So I need a logarithm with the same base. And the input is going to be the output from my exponential function here, 81, and that equals 4. The 4 is the exponent there, right? The 2 right here was the exponent in the exponential form. All this goes to show you that what is a logarithm. In fact, it's one of my questions on the quiz. I'm going to give you that right now if you're going to take the quiz in my class, maybe even on the test. I'm going to ask you, a logarithm is, and the answer is, it's an exponent. All right? It's the exponent here that makes the base equal to that input. So you can think of it like that way if you want to. Remember, if you want to check it, if I took this base right here and slid it over and raised it to that exponent that it is, it should give me 81. 3 to the 4th is 81. Let's look at another one here. This one gets a little bit more tricky because we've got some fractions, and people don't like fractions, right? But I want you to think of something. Remember, anytime we have a fraction raised to an exponent like this, this is the same thing as saying 2 cubed over 3 cubed, okay? And notice 3 cubed is 27 and 2 cubed is 8. So don't be too intimidated by that. Just remember, this right here is the base in my exponential form. So when I write out my logarithm, or convert it to logarithmic form, it's going to be log base 2/3. Our input should be the output over here. 8 over 27 is equal to the exponent, because a logarithm is what? A logarithm is an exponent, right? That's the exponent that goes right there, 3. And you can check it once again. If you slid the 2/3 over, you got 2/3 raised to the 3rd power does equal 8 over 27. So that's how we follow those directions there. What is the logarithmic form? It's hard to say there. What is the logarithmic form of each equation? There you go. Now we can go the other way and say, well, before we look at exponential forms, let's look at what is the value of each logarithm. That's what we're going to do next, because that's the order I already wrote up things. So here we've got a variable, an unknown, x. This isn't necessarily saying the input. This is saying solve for x. A lot of times, like we'll see on number 6, I don't even put the x in there. I just say, what does that equal? It's no different than me saying, what is 10 cubed? You know, there's no x or y value there. I'm just saying, what is it? So I could have written the question like that. What is that equal to? And what I'm asking here is this. If you think about it like this, if you take the 5 and slide it over, we're basically converting it into exponential form here. And I'm saying 5 raised to the x should equal 125. What value of x do I have there? So there's a couple ways to do it. One, you could just know, hey, 5 cubed is 125, so x must equal 3. If you're that good, you're done there. But let's say you don't recognize that 3 goes in for x, because some people don't. Well, let's take 125 and let's factor it out. So I say, okay, I know I've got 125. That's the same thing as 5 times 25. And then 25 is the same thing as 5 times 5. And notice what I have here. I got 5 times 5 times 5 equals 125. That's 3 5s there, or 5 cubed. And so I know that that x right there must be 3 for that to work. Try this one out. You can pause the video, give it a try. The log base 4 of 32 is equal to x. Once again, we're going to take that base, as we convert it to exponential form, we're going to slide it over right here and say 4 to the x equals 32. Well, what value will make that true? So I'm going to take 32 and I'm going to factor it down. And so I've got 32 is the same thing as 2 times 16, and 16 is the same thing as 4 times 4. Now, this is a little bit more complicated because unlike the last one where it broke down into just 5 times 5 times 5, I don't have 4 times 4 times 4 something here. I've got 4 times 4 times 2. So it doesn't work out as nicely, but I'm going to keep breaking this down until I get all 2's here. So this becomes 2 times 2 times 2 times 2. I think I said enough 2's there. There should be 5 2's. 4 right here, and then that one right there. So 32 is the same thing as 2 to the 5th power. And I've got that is equal to 4 to the x. Well, let's rewrite 4 as 2 raised to something. 4 is the same thing as 2 squared. So 2 squared equals 4, and I'm raising all of that to the x power. So 2 squared raised to the x equals 2 to the 5th. Now, if you haven't seen it already, I did a video on the laws of exponents. I'm wearing the same shirt because it's the same day I did this. But go back and watch the law of exponents if you don't understand what I'm doing right now with this 2 squared raised to the power of x. Because I have a power raised to a power, I'm going to multiply those two. So that becomes 2 to the 2x. And that equals 2 to the 5th. And now I've got this base raised to a power equal to the same base raised to a power as well. Because exponential functions are 1 to 1, and I've got the same base here, these exponents must equal each other. So now I can say I'm going to set 2x equal to 5. move me into this corner. I like myself over there better. So 2x is equal to 5. I'm just taking this exponent right here and setting it equal to that exponent. And then I'm going to solve for x. I get x equals 5/2. All right, and then we've got log base 64 of 1/32. So notice here I didn't say equal to anything. It doesn't really matter. Like I said before, it's like if I say what is 3 squared, I'm just saying there is no equal sign there, and that's fine. You say what is 3 squared, it's just equal to 9. You could solve it by saying 3 squared equals y. Now solve for y. Doesn't matter if there's an equals to something here or not. If I'm just saying what is the value, that's what we're going to find. If it makes you happy, you can say equals to x and solve for x there. And now what I'm going to do is I'm going to take and put this in exponential form. So the base here is 64. That's the same base I'm going to have in exponential form. And it's going to be raised, remember if we slide this over, it's going to be raised to the x power. And that must equal what's written right here, 1/32. And now I'm going to take and just do a few things to make life a little bit easier. One, I'm going to take the 32 and raise it up top. Currently, it's raised to the first power. So if I move it up top, it's going to be 32 raised to the -1. And that equals 64 raised to the x power. Now, these are not the same base, so I can't just say x equals -1 because they're not the same base. I want to make them have the same base. I'm going to take 64 and off to the side, just factor that out. That's the same thing as 2 times 32. 32 is the same thing as 2 times 16. 16 is 4 times 4, and then each 4 breaks down into 2 as well. That is, how many 2's? 1, 2, 3, 4, 5, 6 2's. So I've got 2 to the 6th power here. That's the same thing as 64. And I'm going to raise it all to the x power. That equals, I'm going to do the same thing over here. I'm going to break 32 down into a base of 2. Notice I already did that, and I did it right here. So it saved me some work. So 64 is just 2 times that. But if I broke 32 down, it breaks down into 2 times 2 times 2 times 2 times 2, or 5 2's here. So this 32 is the same thing as 2 to the 5th, and I'm raising it all to the -1. And now I'm going to do that law of exponent thing there where we're saying I've got a power raised to a power. I'm going to multiply the 2. So this becomes 2 to the 6x because 6 times x is 6x. And then that equals 5 times -1 is -5. And now I've got these so that they are the same base. And since they're the same base raised to a power, I can set those powers equal to each other. And when I do, I get 6 times x equals -5. And solving for x, I get x equals -5/6. So that is my value right here. This logarithm right there, even without the x there, is equal to -5/6. So those are some examples there. We're going to go through a lot more practice problems, but I want to kind of get you started on how to think about evaluating logarithms and what a logarithm is, algebraically speaking. If you have questions, let me know. I want to encourage you, it's a short video, 15 minutes. Go back and watch it again if you struggled through it, and try to see if you can pause the video at each spot and solve for those things. And then go through and try some of my practice problems I'm going to post. Okay? And I'll try to post some videos to go with it. Let me know if you have questions, and I look forward to hearing from you.